So thank you very much. As said, my name is Lorena Abad. I am originally from Ecuador, and right now I am based in the University of Salzburg in Austria, working with the Department of Geoinformatics in the Risk, Hazard, and Climate group. Our main focus is on mass movements and mainly the analysis, mapping, monitoring, and assessment using Earth observation data. Mostly focused on Sentinel data 1 and 2. And yes, currently I started a PhD position where I will also be advancing a bit on these topics and hopefully sharing them around in future conferences as this. So yes, that's about me, and thank you for introducing my topic. I think I will just briefly repeat is the mass movement susceptibility assessment of alpine infrastructure in the Salzkammergut area in Austria, which is an area here really close to Salzburg. And this paper we work with my co-authors, Daniel Hölbling, Florian, Albrecht, Helen, Zahra, Dabiri, Gerald, Reischenböck, and Dajana Tešić within the project Monteo, which is one of the projects of our lab. And the project was indeed about using mass movement susceptibility to analyze alpine infrastructure in different areas in Austria, but this particular paper was focused in the Salzkammergut area, which was one of our study areas. So to give you a bit of background, this is a picture of my team in the field. And the reason why we wanted to start this project is because we know that the alpine environment is prone to natural hazards, mass movements, like shallow and deep-seated landslides, rockfalls, and debris flows. Climate change is expected to further increase these events. And what we notice is that alpine associations invest very large efforts to give maintenance, to repair, to give good infrastructure to alpine hikers, to alpine visitors. And we notice that infrastructure operators need reliable and comprehensive information about the impact of these events so that they ensure that the effectiveness and the efficiency of their maintenance efforts are just well put. Even though there are several Austrian mass movement studies and it has been argued what the practical applicability of mass movement susceptibility is, it is not so much in the literature, this practical applicability with the concerns of the users. So what we try to do here is to work directly with trail keepers and alpine associations so that they can tell us what is the potential impact of the susceptibility maps that we can create and how they can use them and if this is sufficient for them. Same with hut management. So if there are huts that are at risk, how can they use this information to better give maintenance to this infrastructure? So the idea here was summarizing 3 objectives. We wanted to assess the mass movement susceptibility of alpine huts and trails infrastructure. Wanted to apply and compare 2 statistical approaches. In this case, we used logistic regression and informative value. And the most important one was to evaluate the maps in the field and jointly with the alpine associations to consider the user or the operator needs. So briefly, how the study area looks like. As you see, it's really in the Austrian Alps, in Salzburg, and there are several alpine trails, and it's a very dense network. This is a particular popular area because there's the Hallstatt Lake to the east of the study area where many hikers go very frequently to just enjoy the scenery, and many alpine huts as well. So what we did here is summarized in this workflow with the data and the methodology. What we did was collect landslide inventories. There are 2 sources that we mainly focus on. It's called the GBA, which is the Geology Service in Austria, and a specific one for the Salzburg area. And we try to complement it with a visual interpretation of Sentinel-2 imagery to identify landslides between 2 points in time. So we combine this mass movement inventory to have as the main source of train and test data. It must be clarified here that these inventories are point-based, sadly, and also the quality that we could get out of the Sentinel-2 visual interpretation was also limited to a point difference and not polygon difference. Then we use terrain derivatives that I will enumerate later based on a 10-meter DEM, even though there are many DEMs that are finer resolution for this area. Not many, there's one. But since we were working on study areas in the whole Austria, we went for the 10-meter resolution DEM because that is the one that is available for the whole country. We have landscape factors like land use, land cover, river lines, and geological factors like lithology and tectonic faults. All of these comprise the conditioning factors. So what we did was data split of train data and test data, and we computed an informative value, the logistic regression with this train data, generated the susceptibility maps, computed their accuracy, and obtained rock curves and quality measures. On the validation step, farther than just testing the accuracy itself, what we did was go to the field, get GPS locations of where landslides are happening, and reference this field data to have this field validation. And on the side of how useful the maps are, we also got trail keepers feedback. So we did an online questionnaire, a validation workshop, where trail keepers could look at our maps and tell us, since they're the more acquaintance with the area, how they feel that these maps are representative of their area and their susceptibility to mass movements in that area. And as a last step, of course, we had OpenStreetMap to obtain alpine huts and alpine trail network, and we mapped the susceptibility computed to the alpine infrastructure to obtain an alpine infrastructure susceptibility. So the first thing we did, as I said, is combining these mass movement inventories. Here you can see the three sources of mass movement inventories. We have the geological agency of Austria, it's in green. Then we have the Salzburg one, which is in purple, and we have our visual interpretation, which is in yellow. As you see, we have many visually interpreted points in areas where there were no points of the official inventories. And this is mainly because the official inventories are mostly focused on areas close to roads or close to critical infrastructure, while the areas that we were mainly interested in, which is high mountains or high alpine areas where roads are not normally present, were not so much the focus of the inventory. So that's why with the visual interpretation, we could really enrich this inventory and have more points. We also try to do a slight differentiation between mass movement processes, if it's a slide or a flow, a rockfall, or other process type, mainly for doing also stratified selection of these mass movement processes during the training and testing. And we just computed hotspots of mass movements, high density and low density, to identify areas where we would do validation during our final step of validation in the field. These are the conditioning factors that we used. We computed slope, aspect, plan for curvature, profile curvature, terrain wetness index, land use, land cover. As you see there is LULC. This is a combination mainly coming from the Copernicus data of land use, land cover. And distance to rivers, which is just an Euclidean distance, and distance to faults, again, Euclidean distance, and lithology, which was 1 to 250,000. So very coarse, but this is what we had available for the whole country. Our mapping unit was pixels, 10-meter resolution, because we could not implement the slope units, although this is something that we would want to do to improve our approach. And the results themselves. So as you can see here, these are our two maps of susceptibility, where we identify areas highly susceptible and less susceptible to mass movements. As you can tell, there is very much marking of what the conditioning factors and the most important factors for each of the methods is showing quite an influence on the results. So for example, for the informative value, which is on the left side, you will see that there are very straight lines showing susceptibility, high susceptibility, while on the logistic regression, there is a more smooth representation of the high values of susceptibility. But as you will also see on the lower right part of both maps, the susceptibility is quite low. And this is because if you remember the mass movement inventory, this low right corner does not have many mass movements in the inventory themselves, even though it is a high alpine area where most likely rockfalls and debris flows are happening. But even with Sentinel-2, we could not identify them to include them in the inventory. You can see on the lower right of the slide the accuracy assessment, where our success rate is above 0.7 and our prediction rate above 0.6 for both methods, with a slightly better result for logistic regression. We, as I said, mapped the susceptibility assessment to the alpine infrastructure itself. And here's what you can see. What we did is take the trail network and get them the value of the susceptibility to each segment, and the same to the huts. And then we could compare between these two methods, the informative value and the logistic regression, how these values differ from each other, and how the different methods are showing different results for each of the methods of each of the huts, each of the line segments. There are differences where it's interesting to see how can we overpass these differences to then focus maintenance efforts. There's also this analysis of how many alpine huts and the length of the alpine trail network lies on each class of susceptibility. And the field validation consisted mainly of going to one of these hotspots that we identify, walking around one of famous alpine trails, and detecting where landslides have occurred, mass movements have occurred, and then taking these points and comparing them to the results of our maps with informative value, logistic regression, and seeing in which class, in which quintile, in this case, do they lie. So in the highest 20% of susceptibility, highest 40%, highest 60% is where all of the landslides lie. So as a positive point of this, there were no points where there were mass movements occurring, but the susceptibility was low, so that was positive. But of course, there are differences between both methods, which we also found interesting, because some places happen to be have a high susceptibility in one method than in the other. And what we did then further is show these results to the trail keepers and the alpine associations, and so that they let us know how useful they think that this is for each for different scenarios. So what they mainly said, the majority, was that they find these maps useful for planning new trails, for calculating costs of what could be maintenance efforts. And in general, also with the online questionnaire, in many cases there was also not such a big reception of these methods. In the case of the scale is too small, it needs field validation, things differ between two methods. But in general, they also like how the representation of the trails and huts were shown with many layers of information. So to conclude, what we discovered with this study is that these susceptibility maps are a powerful way to convey information about areas prone to slope instability. And alpine associations can use this information to plan their maintenance work and to identify infrastructure that is in susceptible areas. The mass movement inventories and the conditioning factors have a very strong influence on the resulting susceptibility maps, and further efforts are needed to demonstrate the practical applicability and to increase the acceptance of the susceptibility maps among the potential users. So how to make the resolution, the scale better so that they can use it more in practice. So this is a summary of the study, and I thank you very much for your attention to this very short presentation. This was a part of the project, as I say, Monteo, which was funded by the Austrian Research Promotion Agency. And there you have contact also to our Risk Hazard and Climate Lab, or my own contact if you ever have any questions, if you see this presentation afterwards and didn't manage to ask questions right now. Thank you very much.